Hi everyone, thanks for joining me again. So today what I want to do is show you how to generate your unsigned algorithm in a uh, resolution independent manner. So you can choose what resolution you want to do it as. We're going to do this all online using some links and tools I've prepared and published for you. If you want to do this actually above around 4096 pixels or larger, you probably need to figure out how to run a local dev environment using Python and Conda, and there's a lot of good tutorials in that. Maybe some people in the comments can link a recommended one, but I figured this is a kind of just to show you that you can in fact run and generate your unsigned algorithm using all the data that is available on chain, which is kind of the main point of this this project, right? Is that whereas most NFTs are basically references or links to other things. Here, what we're saying is at least the DNA or the sheet music, pick your analogy, is stored on chain and is not dependent on any other external system. So let's switch over to my screen, right? So there'll be a link to this GitHub repo down below. This is my public GitHub account. It doesn't really have anything on it, so don't laugh too much. So if you go here, when you land on it, the README that's in this repo should be here, and it just explains that we're an on-chain NFT project in Cardano. And then to click the binder button below, this button right here, and after it loads, double click on this unsig_gen IPYNB. So I'm going to open that in a new tab and throw it over here. This takes a little bit of time to load depending on when the last time someone ran it is. So what I'm going to do is I'm actually going to, looks like it's loading in already. So if we go over here to the unsigned algorithm site, I'm going to find an unsig that I want to make. So I'm just going to do what I like to do, which is just keep clicking random until I find something that ooh, that's kind of nice. What do you guys think about that? Is that worth making? Okay, so I'm gonna make this one. This is 12028, and so what the instructions told me to do was to double click this unsig_gen.ipynb. All right, so I do that, and then this basically shows us all the kind of code that is in here, right? So this cell, if you've never encountered it, a Jupyter notebook is a kind of hybrid, kind of like Word document plus coding environment, and it's one of the reasons I chose Python to do this in, because it's a little bit easier to kind of encounter. So this instruction says press Shift plus Enter to run a cell. All cells should be run in order from top to bottom. So if I hit Shift Enter on my keyboard, this little blue thing goes down. That means I ran this. This is just a comment, so it doesn't really matter. But you see here we get to our first line of code where we're importing NumPy and this pillow image library. So we hit that, and now that this little 1 means that that's run. Then we set some parameters. Here, this is actually where you can change the size of your image. If you were running this locally after cloning the repo to your own environment and setting up Python, you could change this to a higher resolution. 4096 tends to be the max that this little online environment can handle. Based on, I think it has what, 2 gigs of RAM down here it's saying. So that's about the limit. So here's the trickiest part. Input your unsigs. You put an index number in, the number of properties, and the value of the properties. This is where it gets, this is the trickiest part. So in the comment down here, we say this unsig is equal to, and this is called a dictionary or a map. So we need to replace this index with the index of our guy, or unsig. So I'm going to replace this with 12028. One thing to be careful of is usually in unsig land, we like to use the leading zeros. Like if you go to this URL up here, let's say that you had, I'm going to copy this URL. Let's say I had unsig 28. You need to put in the 00028 to get to that page. But actually, because this is an integer, if we were to do 28, we only want to do 28 like that. Over here. I'm going to zoom in on this a bit because I think this is probably small on the screen recording. So because we're doing 12028, let's keep that. The number of properties, it says right here, this unsig has 5 properties, so we're going to change this to 5. And then here it gets pretty easy. The order is a little bit different, but you can see here the first thing we want to grab is the multipliers. So let's look at multipliers. We're going to grab multipliers. We're going to select them, copy, and paste. That simple. If you note here, this will be more important later on. Words are enclosed in a single quote, and the numbers aren't. That's because these numbers are either floats or integers. This is a kind of number in a programming language, whereas these other things are strings, or a string is just a sequence of characters or letters. So if you were to put up here 1 in quotes like that, or single quotes like that, it would think that you're referring to the character 1 rather than the number 1. So you just want to make sure you're not doing that. And if you're copying and pasting from this page, basically the easiest way to make sure you're doing it right is just to select the stuff that's between the square brackets, and then put your cursor into the square brackets over here on the left, and then just directly copy and paste it over, right? So once this is all populated, all you have to do is hit Shift Enter again, or if you're scared, you can hit this play button at the top, which is the way to run a selected cell. And then we do this, and then one more time we run this thing, and this is just a bunch of code which basically takes these arguments and turns it into an unsig. And then over here at the bottom it just says look over there, you should see a file named unsig underscore your unsig number. It's a PNG. It's going to appear over here in a second. This is a free instance, so it's not the speediest thing. It takes me about half a second to record this, or to make this when I'm running it on my computer. Takes a little bit of time when we're over here. So right there, unsig underscore 12028 just appeared over here. If we double click this, we should be able to see it in the viewer. And what do we have? We have, right, that looks like that. So if we want to actually download this, you right click this and hit download, and now you've downloaded your unsig, right? So that's the easy version. And you might say, well, that's great, but how do I know that, if this website goes down, how do I generate my unsigned algorithm? So the next version of the instructions, we just went through the easy version, we'll go through, is a little bit more complicated, but runs basically the same way. So if you were to do this, you go over to this site called cardanoscan.io. I'm going to do this in this window over here. And what you're going to do is you're going to take the transaction, right? If you're in Daedalus or Yoroi, you can see the transaction that you received your unsigs from, and you can select that thing and you can paste it into the search, and you'll get something like this, right? This will show you the transaction. And what's interesting about that is you should be able to see, oh, you received unsig 17429, 17667, and unsig 26801 in this transaction specifically. So what you can do is you can click, there's a few different ways of doing the same thing, but if you click this metadata over here, and then you click this value, this will give you the metadata of the entire transaction, or of all the mints. So in this specific one, there's 3 different ones. So you would have to scroll down if you wanted to do, what was it, you see up here, this is unsig, this is the metadata for unsig 17429, this is the metadata for 17667, and down here is the metadata for 26801. I don't know what this is, but let's do this. So if we look at this while we're doing this, I now have that same environment open over here. We can just type this stuff in. So we're going to do unsig 26081. The number of properties, if we're looking in here, right, this is the relevant area we're looking at, is 6. And here's where we have to be a little bit careful because of how, if you were to just copy and paste this whole thing in from here over to here, you'll notice that on the right hand side in Python, these are called keys. They're surrounded by single quotes, and over here they're not. So it's not really directly copy and pasteable, but you can kind of follow along here, and you can see this is just dependent on the viewer, I believe, and how it's actually written into Cardano. But let's make sure that we have this right. So we're going to take colors, right, and we're going to put that in here. So colors are now replaced. The distribution, that's actually the same. Single quotes and double quotes doesn't really matter for what we're doing anyways. Multipliers, here's where we gotta correct this a bit. If we were just to paste this in after copying it from here. These multipliers are surrounded in quotes. So as we noted before, you shouldn't have numbers in quotes, because otherwise the interpreter will think that you are talking about the character one rather than the number one. So we go in here, sorry, I'm doing this in a very dumb way, and make sure that all of these are not like that. So probably the faster way to do that rather than that is just to type these in the right order. So for rotations, rather than copying and pasting, I'm just going to type these 0, and then 180, and then 270, and then 0, and then 90, and then 270. And this should run. And now we hit Shift Enter, Shift Enter, Shift Enter. And now what we're going to be looking for over here is unsig, what? 26081. And we don't know what that looks like. It's taking a little bit of time, so let's pull it up over here. 26081. Let's look at it. It just finished. 26081. That's not right. What's going on? Did we not write it incorrectly? One 26081 is 114. 4. 26801. I did that wrong. 26801. So if we look at 26801, you can see that these match up. I named the number wrong, so we've had this one's properties and this one's properties. So that is it. Thank you for watching. Last thing that maybe is relevant here is that you can see these are kind of stored as, again, DNA or sheet music on Cardano. But when I announced the other day that what I want to do is basically do this project kind of again, not to make the same pieces, but to kind of really interrogate this idea of how do you make art on a blockchain and like blockchain native art. What we'll be doing that is so exciting to me is right here we have sheet music, but basically the orchestra or the ensemble is still kind of off chain on your local computer, and I'm okay with that because, you know, following a set of instructions and standard kind of development practices allows you to produce your unsig independently on almost any kind of modern computer. But what will be really cool is if we can kind of generate these things and the execution environment is actually on chain on Cardano, and you can directly get your, maybe an array. You might still have to do some cleanup. I'm not, I've fallen behind in my Pluto studies, but you should, what we want to do is try to figure out how would we do something similar natively inside of a smart contract. So anyone who buys an unsig and holds an unsig until this project is done will basically be receiving one of those in their wallet. So keep an eye out for that. And thank you all for participating. It's been really fun. It's been really crazy. So I'm going to cut the broadcast there. Thank you. Bye-bye.